Okay, yesterday in class, you guys learned about linear relationships and then also graphing them either from a table or vice versa with an equation. So I just wanted to briefly talk about what we did yesterday. First of all, let's describe what a linear relationship is. Remember, in the word linear, okay, it actually has the word line. That means that any linear relationship is going to make a straight line when we graph it. Okay, and so if I'm talking about a linear relationship, when I'm just adding the word relationship, it's just talking about the relationship between the x and the y values. Okay, so the definition of a linear relationship is, remember, it makes a straight line, but because the reason why it makes a straight line is because there's a relationship in which there is a constant rate of change. And remember, that could also mean slope. It could mean unit rate, our constant of proportionality or rate of change. And it's between our two variables. Remember, the variables would be our x and our y. Okay, remember, we can find if it's constant or not between our x and y variables because I do y over x. So, a linear relationship, whenever I graph it, is going to make a straight line. And the reason why it's a straight line is because it has that constant rate of change. Now, a lot of you guys are getting confused with linear and proportional. From the linear relationship, it can either be proportional or it could be non-proportional. So all linear relationships are either one of these. Now, proportional means two things. It has to go through the origin, which the origin as a coordinate is going to be 0, 0. And it has to have a constant. Constant rate of change. I'm going to put rock for rate of change. So if I'm looking at my formula here, okay, for a proportional linear relationship, my formula is going to be y is equal to mx, okay, but the b part is going to be plus 0. Now, a non-proportional linear relationship is when it does not go through the origin. Okay, which means in our equation, okay, that b is any number besides 0. So if I'm looking at my equation, this would mean y equals mx, and it could be plus a number, any number, plus or minus, doesn't matter. Okay, so these are the only, everything is going to be a linear relationship. It's either proportional when the b is 0 or non-proportional when the b is a number. Okay, now remember that all linear relationships are written in this form, y equals mx plus b. Okay, the m represents a couple things. Mostly, we're going to recognize it as the slope from now on. Slope from a graph we can figure out by doing rise over run, or y2 minus y1 over x2 minus x1. Okay, however, remember, slope has a couple different names. Okay, it's also our constant of proportionality. It is our rate of change. It's our unit rate. And also, remember, we just flipped the equation from what we always know is y equals kx. K is just now m. It means the same exact thing. Okay, so really m is our k. Now the b is what's new. We've always just had y equals kx, no number, or y equals mx without a number with plus 0. Now this b is going to represent a number, which means it's non-proportional. Okay, and this b is called our y-intercept. So the two, I'm going to probably remember that the m is going to be the slope and the b is the y-intercept. That's what I'm going to label these as for now on in class, so you need to make sure you know the difference. The y-intercept is exactly how it sounds. It is where the line intersects or crosses the y-axis. Okay, so if I was looking at a table, okay, my XY table, it's going to be when X is 0, whatever that number is that Y intercept. Or if it's on a graph as a coordinate, it's going to be 0, comma, whatever that number is. Okay, so that's something that you have to remember. Y equals mx plus b is the ultimate equation for all linear relationships. M is going to be my slope, and b is going to be the Y intercept. Okay, so if we look at a couple examples now. So say I'm looking at a real world proportional relationship. Okay, so I'm going to look at a proportional linear relationship. Okay, let's use my Sonic example. So for my Sonic example, okay, today it's going to be happy hour, and every single drink from the time that I'm going to be there is going to be $2 no matter what. So let's say X is going to represent our number of drinks, and Y is going to represent our total cost. If I said that each drink is $2, okay, I'm trying to find an equation that would work for this situation. Okay, so if I have Y equals mx plus b, okay, my Y is going to be the same, my X is going to be the same. Those are our two variables. The slope, or the rate of change, is what's changing. So from this problem, okay, the number of drinks is going to be changing, and it's going to be changing based off of the cost. So Y is going to equal the amount of money, which is $2 per drink, to figure out the total cost. Now, do I have an additional fee? Do I have to pay a certain amount of money to get into Sonic or to order? Does it cost me to order? No, in this case. So my B is really that plus 0. Now, we don't have to write plus 0, but if I did, we know that this is a proportional relationship because that means it goes through the origin. So based off of this equation right here, okay, I need to be able to fill out an XY table. So if I have my XY table, I always need 0 there. So I'm going to start with 0, and I'm just going to go up by 1s. I'll go up to 3. I'm buying drinks for 3 people today. So since it goes through the origin, okay, X is 0. So since it's going through the origin, my Y is going to be 0. That also means X is my number of drinks. So if I don't have any drinks, I don't have to pay any money. So the total cost is 0. Okay, so now if I look at one drink, the cost of one drink is going to be $2. I know that based off of just, it's common sense. However, I need to be able to explain that in this situation with the equation. So if I have Y is equal to 2X, that's my equation for this situation. All I'd have to do is plug in the X variable in for the X in the equation. So Y is equal to 2 times 1, and I can solve that, so Y is equal to 2. Okay, I could do the same thing when X is 2. So I'm buying 2 drinks now. I plug it in my equation. It's $2 per drink, and I'm buying 2 drinks. The total cost is $2 per the number of drinks I'm buying. So I'm buying 2. When I multiply those together, I have Y is equal to 4. Okay, if you notice, the rate of change is going up by 2 every single time. So if I buy 3 drinks, the total cost is going to be 6. Okay, so from there I'm able to create my table. Now if I'm looking at a non-proportional example, okay, let's talk about an arcade that's nearby. It's called Tornado Terry's. I'm sure a lot of you guys maybe have been there. Okay, so Tornado Terry's Video Arcade. Okay, at Tornado Terry's Video Arcade, there's a couple rules. The first thing is it costs $5 to get in. Even if you're just going to watch friends play video games, it's still going to cost you $5. To get into that door, you have to pay $5, so everyone pays. Okay, after that, each game that you're going to play is going to cost $1.50. Okay, so my equation here, if Y again is the total cost, and X is going to represent the games played, the number of games played or you want to play. Okay, my equation is going to be Y. The total cost is going to be $150 per game, which is my X. Okay, but I have to pay that $5 to get into, so I'm going to add 5. So this is my equation. I have to pay the $5 to get in, and then based off of how many games I want to play, I'm going to multiply that by $1.50, $1.50. Okay, so so using my equation, I need to fill out an XY table. So here's my XY table. X is always on the left, Y is on the right. What does my X represent here again? Okay, it's going to represent my number of games. And my Y represents what? Total cost. Okay, so again, we always need 0 to be my X. So 0, 1, 2, 3, and 4. Okay, so now, looking at my equation, remember when X is 0, this is saying that the number of games, if I play 0 games, what is going to be the cost that I have to pay? Is it 0? No, remember, you have to pay $5 to get in. So even if I don't play any games, I still have to pay that $5. And I can figure that out by plugging in my equation. So Y is equal to 150X plus 5. And I'm going to plug in 0 for X. Remember, whenever we plug in numbers, we put it in parentheses. So I multiply 150 times 0 is 0. Plus 5. Y is equal to 5 when X is 0. If I play one game, Y is equal to 150, plug in one game, plus 5. I use PEMDAS to solve, so 150 times 1 is 150. And I'm going to add my $5. So if I play one game, the total amount of money I'm going to spend is $6.50. Okay, go ahead and figure out 2, 3, and 4 games by yourself. Like, pause this video just to take your time. I want you to show your work exactly like the way we did. Okay, once you check your work, okay, with your group members, look and see to make sure that you have exactly what I have. If I play 2 games, the total amount of money I'm going to be spending is $8. If I look, I'm going up by my constant rate of change every time. I'm adding 150 every time. So, at 3 games, if I add 150 to 8, I'm going to add, my total cost is going to be $9.50. 4 games is going to be $11, and so forth. Now, we have to use this equation because it's not going to be that easy. Say, I want to play, I'm going to use another side. Using that same Tornado Terry's Video Arcade, say I want to play 547 games. Okay, remember in our equation is Y is equal to 150X plus 5. Okay, X represents the number of games, Y is the cost. I have to pay $150 per game plus the $5 entrance fee to give me my total cost. So if I'm talking about 547 games, is that my X or my Y in this situation? What does that represent? The number of games represents what variable? Okay, it represents our X. So in this problem, X is going to equal 547. I want to play that many games, and I want to figure out how much money I'm going to spend, which is my Y. So I'm going to use my formula. Y is equal to 150X plus 5, and I'm going to substitute 547 in place of the X. Remember, put it in parentheses. And I'm going to solve. So I multiply this. You may use your calculator. $1.50 times 547 games is going to be $820.50. But don't forget, I have to add the $5 entry fee. So my total cost is going to be $825.50 at the Video Arcade. That's a lot of money for spending money on games. Now we could also do the opposite way with my equation. So say my dad, who is Papa Fountain, because Fountain was my maiden name, he told me that because you guys are so awesome, he's going to give every single person in this class $30 to spend. Okay, you can't go over. It can't be $30.01. Can't be anything more than $30. So if this isn't the amount of money you have, you need to figure out how many games you can actually play. So is this going to be my X or my Y variable in this situation? Remember, X represents the number of games, Y is the total cost. If I only have $30 to spend, that's going to be my Y here. So now I'm figuring out how many games it could be without me spending more than $30. So if I have my equation again, Y is equal to 150x plus 5. They give me my Y. So I'm going to plug in $30 for Y. That's as much as I can spend. I need to solve for X. So remember, this is our two-step equation, which we worked on last week a little bit. Okay, I need to get X by itself. So I'm going to undo PEMDAS. So I'm working backwards. I want to get rid of the number that's not attached to the variable. So I'm going to subtract 5 on the left and subtract 5 on the right. So now the only thing I have left over on the right is 150x, and over here 30 minus 5 is 25. Now to get x by itself, the operation here is multiplication. So to get rid of that, I'm doing the inverse, which is division. I'm going to do that on both sides. It cancels out on the right, so now I just have my x. And if I use my calculator, 25 divided by 150 is going to be 16.6 repeating games. Now, can I play 2/3 of a game? No. So my answer, if this was a star question, is it going to be 16 or 17 games? Okay, just 16 games, because remember, my dad, Papa Fountain, told you he's not spending any more money, so don't go and ask him to pay that 17th game or finish out. Okay, you only get to play 16 games. Okay, so that's our example of a non-proportional linear relationship and why we have to use this equation to figure out a little bit more in depth or harder things. So today you're going to be doing a lot of that. You're going to be given the equation and you have to find the table, but you're also going to have to be able to graph it. So just talking about graphing linear equations real fast, we're going to write out the steps. Graphing linear relationships from equations. And you did this yesterday a bit. But the first thing is you're going to be given an equation. And this equation is going to be in the form of y equals mx plus b, which is our form of all linear equations. Okay, the next thing that you should do, this is my equation and I need to graph it, what do you think would be my first step? Okay, I'm going to plot my y-intercept because it's already given to me in my problem. Remember, the b represents my y-intercept. So whatever that number is, that's where it crosses over the y-axis. Okay, b is my y-intercept. And that coordinate is going to be 0, whatever that b is. After I plot my y-intercept, which crosses over my y-axis, now I'm going to use my slope. Remember, our slope is a fraction. And if it's not, we're going to make it into a fraction. Since it's in a fraction, we're going to use it as rise over run from the point that we just plotted. Okay, so rise over run from our y-intercept. And then the last step is we're going to connect our points to form that linear line. Okay, so that's our steps. You can leave this on your desk when we go over the homework assignment. I'm going to set you up so you may pause this if you need a little bit more time to copy these notes. If you are done, you can go ahead and head a piece of paper with your name, 4-1 worksheet. Today is the 1st, and your class period with Friday. It should look something like this. Go ahead and take a second to do that. Someone please hand out the worksheet 4-1. Okay, and let's go over what I expect you to do on this worksheet. So here's the worksheet. I already headed my worksheet. You can fold it in half if you want to. If not, you can draw a line. So for number one, I'm going to be writing my equation. So this equation is y is equal to 4x plus 3. Okay? You are not able to use your calculator on this paper at all. Do not use your calculator. So if I were to have to find the x or the y values using this equation, I'm going to have to plug it into my equation for every single point. So this is what I expect you to show. So for this first point, they give me -2 as my x value. So what I have to do is I have to rewrite the equation. Y is equal to 4x plus 3 every time you write that equation. They give me the x value of -2. So I'm going to plug that into my equation. So I have y is equal to 4 parentheses -2, because that's my x value they give me, plus 3. Now I have to solve. So 4 is equal to -8. I'm sorry, y is equal to 4 times -2, which is -8, plus 3. And -8 plus 3 is -5. Circle your answer, and you're going to put -5 in that first box. Okay, if you have room, you can do it right next to it, or you can keep going down the page. The next point, they give me x is -1. So I'm going to write my equation. I'm going to substitute x with -1, and I'm going to solve. So y is equal to 4 times -1 plus 3. Using PEMDAS, I have to multiply first. 4 times -1 is -4, plus 3. If I add 3 to -4, I'm left over with -1. So -1, when x is -1, y is -1. Okay, the next point is 0. So again, my equation is y is equal to 4x plus 3. I'm going to plug in 0 for x. Y is equal to 4 times 0 is 0, plus 3. Y is equal to 3. Circle your answer, plug it in. Notice, when x is 0, y is 3. That's also the point of our y-intercept, which I can double check with my equation. Okay, this is my y-intercept. When x is 0, that's the y. Same thing here, and I can show my work by plugging it in. You're going to be doing this for for when x is 1 and when x is 2. Okay, so y is equal to 4. I'm going to plug in 1 for x, plus 3. 4 times 1 is 4, plus 3. Y is equal to 7. 4 plus 3 is 7. I'm going to plug it in. Okay, and then the last one. Y is equal to 4x plus 3 every time you write the equation. I know it's tedious, but you need to make sure that you're writing it out every time. If it doesn't look like this, you will be handed back the paper and you're going to have to do it all over again. So you might as well do it right the first time. So y is equal to 4. I'm plugging in 2 for my x value now to figure out what my y is. Y is equal to 8 plus 3, which means 8 plus 3 is 11. Alright, so now that you have your table filled out, I'm making sure my directions, I don't have to answer anything else, make a table of values for each equation. So I did that. You are to do this for number 2, 3, and 4. Okay, number 5, same thing. You're going to have to show your work, and then you're also going to have to plot them. So remember, use your notes when you plot the points. Okay, you start with the y-intercept by plotting the y-intercept, which would be this number right here, and then from that point you do your rise over run using your M. You're going to do that for 5 and 6. Number 7 and 8, use your vocabulary and what you know to solve those questions. On the back, this might look very familiar to what some of you did yesterday, but 9 and 10, you're going to do the same thing by plugging each of those x values into the equation. Number 11 and 12, you're explaining why it's not proportional. And number 13, you're going to fill in the table using your equation, so show your work on a separate piece of paper, and then graph. Number 14 is making sure that you understand everything by answering that question and filling it in. If you have any questions, you may ask your group members quietly, but other than that, it should be independent practice. When you come in on Wednesday, this will be the first thing due, so make sure that you are coming in for tutorials if you don't understand. Okay? Have a great day.